a smart man learns from their mistake, but a wise person learns from the mistakes of others. So hopefully you can learn from my mistakes and you don't have to make them yourselves. That said, let's go into our curriculum today. Do we have any questions from yesterday's curriculum? So yesterday we talked about conditional execution. We talked about using an if statement, an elif statement, an if, an elif, and an else statement. We also looked at nested loops, right? And we went ahead and looked at different ways that we can address errors for user inputs. Okay, so in a nutshell, that's about it, what we did yesterday. Today, though, we're going to look at loops and iterations. Our code has been running only one time all along, so we want to set it up so that it's repetitive, so we can repeat it. Okay, so that's what our focus will be on today. So a few things that we need to do. We'll go back and talk about variables a little bit. We'll look at iterations that are indefinite, and then we'll look at iterations that are definite. And we'll see how we can exit out of an iteration if we meet a certain condition. All in all, we'll learn how to run the same task multiple times, and we'll also learn two different types of loops and when we can apply them. My goal will be to get this done in less than an hour so that we can do a lot of practice, because there's a lot of practice you can do. And what we need to be doing is having fun. Try out many scenarios. And like I said, coding is a creative art. So there might be 10 different ways of writing the same piece of code. You just have to build your own signature, stay consistent, and then make sure that you avoid errors. All right, so let's get started. Variables. What are variables? Remember we said variables are just a place in memory, right? Like a bucket where you put stuff inside. So normally you want to be able to create that space in memory. Think about giving birth to a child. You want to first give birth to the child before you give the child a name. Okay, I know nowadays things are different. People do their baby showers and choose their names of the babies before they're born. But without the baby being there, you can't really assign a name to it. So declaring a variable is what's known as creating that, or creating one. So a common error that we might have, as you can see here at the bottom, we might say we want x plus 1 to be assigned to x. This will give us an error. It's a common error because we are trying to update the value of x when x does not really exist at that point. So it gives you a name error when x is not defined. The way you can avoid this error is to make sure that you initialize, you assign a value for x. Just a simple assignment needs to be done before you can update that value. So this is what needs to be done here on the right. You say x should be equal to 0, and then you can keep updating it as you need. So when we're looking at a loop, you want to make sure that you assign a value to your variable before you get it into the loop, because the loop is going to be updating it. Does that make sense, everyone? Good. So let's jump straight into while loops. While loops, again, they are indefinite. What do I mean by indefinite? There are some cases when you don't know how many times your code is going to run. That means it's indefinite. You don't know the number of runs it will take. For instance, somebody puts you at the door of a bar or a nightclub and they say, okay, you're here to collect tickets. So all you're doing is just punching in the number of people that are going in. You don't know if there's going to be 2 people coming in, if there's going to be 100 people coming into that party. You're just there to keep track of the number. Once you get to a certain number, you can then say, stop, we're at capacity, okay? But you're not quite sure. So a few things here. You write your while statement. You start with a while word. You give it a condition. We talked about conditions yesterday. So a condition is an expression that is either going to return true or false. If this condition is true, then whatever is within this body, the indentation, the body of your loop, gets executed. Just like the compound statement we talked about yesterday for the if else, if else. Okay. A compound statement ends with a colon. So after that colon, this block of code gets executed if this condition is true. If the condition is not true, the whole block of code is skipped and you go to the next line of code. Does that make sense? So again, evaluate the condition, which will result to true or false. If the condition is false, you skip and you continue execution at your next line. If the condition is true, execute the body and then go back again to the condition. So one thing that happens is within the body, you usually update the condition or the counter. If you're saying while x is greater than 0, do all these statements. Somewhere along the line, you're going to say update x by adding 1 or by subtracting 1. Okay. And then eventually you want to get to a point where that while condition is no longer true. And then you skip out of your loop and execute the next statements that follow. The else block is optional. You don't really need to have it in there. Most people have it in there for readability or just to reinforce what you're typing. But often you will not see that. You just have these statements just start right here in the indentation without the indentation and continue. So it's very useful if you're going to look at a text file. You want to see the contents of the text file. You can use the while loop to check if there's another line in the text file. Okay. You can also use it to check if a user has finished entering values. So when we're asking for the user to input a name, input stuff, you can say, okay, input a value or input a particular string to show that you're done, or input a particular number to show that you're done. So all you want to do then is you say while that value that they entered is not what is the terminating value, then keep doing this. And it's going to go on and on and on without ever ending. Does that make sense to everyone? All right, but a few tips to mention. Again, the else block is optional. In some cases, if you have this while condition and it's always true, this means your code is going to run forever and ever and ever, well, without end. Okay, so you want to make sure that when you write code, you make sure that your condition is something that is correct. If your condition is incorrect, it's going to run until your battery of your computer runs down or your CPU gets too crazy. I mean, you definitely want to make sure that you avoid a scenario like that. Does that sound good to everyone? So let's take out a quick example here. Let me escape from that. And let's go into our Jupyter Notebook. So day 4, let's add a new, oops, sorry, that's not what I wanted. I need to add a new Anaconda notebook. I'm going to rename that and call it day 4. So in this case, we want to try while loop. Maybe I should not use the word try. Let's say, let's execute a while loop, okay? So how do we do that? That's just a comment. First, we want to give our variable a name. I'm going to call it counter. That's the name of the variable. We need to initialize it. We need to give it a starting number. Let's say 10. The variable is 10. Now I can write my while and you put in a condition, okay? The condition in this case has to be an expression, which is either going to be true or false. So now I'm going to say while the counter, if I can spell correctly, is greater than 0. So it's going to test this condition. If this counter right now it's 10, it's greater than 0, then I can go ahead and print it. After printing it, I need to update that counter. So to update the counter, I'm going to type it very mundanely. Counter should now be equal to counter minus 1. Does that make sense? So I'm going to start from 10. I'm going to check if 10 is greater than 0. Yes, that's true. It's going to print out 10. And then the counter is now going to be 9. And then it goes back outside and runs the code again. It's going to keep running it until the counter is no longer going to be greater than 0. So I can go ahead and get out of that loop and decide to say, want to print a statement that says done. Okay, so that would be a simple example of making a countdown program. Now I don't really need an input. If I execute this, you can see that it counts from 10 all the way down to 1. When it gets to 0, when counter is equal to 1, 1 is greater than 0. So it prints 1, and then your counter now becomes 0. When it goes back out, 0 is not greater than 0. So it gets out and it's done. What questions do you have? Everybody good with this so far?
Yeah.
Excellent. So if you want to make it more dynamic, you can ask the user to enter a number, right? And let's say counter input. And we get the input function and say enter a number for your countdown. Say enter a number for your countdown. Now we want the counter to be, let's make it an integer. That way we don't get trouble. So integer would be counter underscore input. Oh, I did not spell it correctly. That's why. Good thing I checked. Okay. So without doing my user validation, the try catch, I'm assuming that the user is going to be really nice. If I press play, now it wants me to enter a number 4. I cannot spell. Okay, count down, and the number I enter is 50. If I press enter, it's going to count down from 50 all the way to 1, and it's done. Now let's make it something that's reasonable. Maybe 5. We enter that, and we put 5. Execute it. Oh, sorry, I should press enter, and it counts it down. So that's how a while loop is going to execute. Now let's go back to our code and take a look at it. So does that make sense what we've done, writing a while loop? Questions, comments, concerns?
That's good.
Okay, good. We can also set it up to be infinite. If we want it to be infinite, the way we'll go about doing that, let me escape from this again. The way we'll go about doing that is to make sure that this condition is true. If we want this code, it's going to crash our system because it's always going to be true. This is going to keep looping and looping and looping and never end.
Mhm.
Okay. Except we'll talk about this later on today. There's a way that we can get out of it. So let's not do that. Let's make sure that at some point in time, this condition is going to be false and then we can get out of that loop. One thing to point out again is the loop is the outer repetition. The iteration is the inner repetition. Okay. So each time you go to an iteration within your loop. Okay. So you have an iteration. The first iteration is when it's 10, assuming that we're still having 10 here. The second iteration is when you have 9. The third iteration is when you have 8, and so on and so forth. So that's what we get when we look at a while loop. Again, in this case, we were not really sure how many times the loop is going to run. You see a lot more of those as well